How's it going, guys? Bubbleman here with Andrew from Sample Automation. He flew out from Massachusetts.
New Hampshire, Massachusetts.
New Hampshire, Massachusetts. New England. He came from New England. Get in the car. Get in the car, right? Anyway, we've been talking, myself and Corey, his partner, who's responsible for a lot of the cannabis-based information. Andrew, you're more focused on the software, the sensors, all the actual hardware.
Yeah.
So Andrew's going to walk us through the Rosin Reactor today. We've got, about 1,800 grams of apricot kush rosin. Kind of looks like peanut brittle right now. And we're going to get this into the Rosin Reactor, which is right over here. And I'm going to have Andrew walk us through what this is, how it works, break down all the components, the software, the brain, and the vessel. And then you guys will have a great understanding of why it's important to have a piece of machinery like this. This is so you can avoid watching bubbles as you decarboxylate and stabilize your resin for vapor carts. So I'll put it over to you, Andrew.
All right, well, our Rosin Reactor system comprises of three main components. One is a laptop, which is going to hold your software, and our calculator. You've got a control box, which can control two individual vessels, and the third is our vessel/mantle assembly with our manifold on top. The way this system works, it's able to track both the ambient air temperature and the pressure of the vessel. You have the internal product temperature, as well as you can then control the ventilation and burping of gas, as well as the inert charge of nitrogen gas inside of it. We then fully control the mantle, and we are able to monitor the internal temperature of the heating element to dial in the exact temperature and track everything both on screen, as well as control all of the components of the system. Inside of this control box is our brain, as well as a temperature controller that will communicate both the brain, but also control the individual temperature of this manifold. Mantle, apologies. We have different vessel sizes. This is a 1 liter vessel. This would be a ½ liter vessel. We have 2 liters, 3 liters, and 5 liters, respectively. And they all simply attach with a 3/8 compression fitting.
And so you've got the one vessel right now, it's plugged into over here. This manifold is all plugged into here. And then there's also another one on the other side that you're not seeing, and that's what he was meaning in regards to you can run 2 of these systems off of one brain. The software itself will actually run 4 brains.
It'll run up to 4 brains, so you can have up to 8 vessels, all of varying sizes. We just simply spec it out depending on what your process requires as a facility.
Okay, beautiful, excellent. So explain to people why this is better than, I mean, this is a very simple question, and I know the answer myself, but why are people going to be more interested in, instead of using vac ovens and watching the bubbles finally stop in their material to figure out their decarb time, what is this going to offer us that is going to sort of take it to the next level, preserve volatile organic compounds, and ensure that the THCA has been converted to THC so that you don't have crystallization in your carts?
So what we found is the usual process of decarboxylation obviously creates CO2, which generates a pressure. From that, the typical tech has always been to watch the bubbles. And what happens when you get towards the end of that process is there is a saturation of delta-9 and terpenes that occurs that starts to hide any of that reaction. And you don't see it on screen here, but I'll briefly show you on one of our brochures, is you can see there is a taper off to the green line of the reaction. That taper off could take 2 to 3 times longer than what you initially expect, meaning the last 15, maybe 10% of THCA that you believe is no longer inside of that material is still remaining in it. And it won't show until 5 to 10 days later after you've filled all of that product into cartridges, which can occur in either crystallization or cloudy cartridges where you lose the perfect clarity that you should have. to create the most optimal product and preserve the most amount of terpenes while doing so.
And that's like microscopic crystallization of THCA. They're not creating giant crystals, but they're just these microscopic ones, and they do create a very sort of cloudy, not ideal for shelf look.
Correct.
Okay.
You additionally have some more controls where everything in terms of this software is all built in as one. You have a logging function that you can start and stop. You can disengage and engage the tanks individually. You can charge them as well as discharge from buttons on screen. The system is designed to work away from a laptop, where if you have a TV connected, you can actually pull out the graphs and you can move these to different screens if you want to. You can also, if we had multiple tanks, you can turn this graph into a multi-graph setup. So if you had 4 tanks, you can show all 4 graphs all at once, or you can show all 4 graphs on a TV. The whole system is network connected, so you don't actually need this laptop to stay with the system. You can place this laptop wherever you'd like in a facility, simply plug it into your network, connect the software, and everything can be controlled, and you can simply leave up and display everything that is going on, but none of your users will have control of what's going on. Only a specific individual in your facility needs to be able to get access to that computer. The workaround we found is we use a program called AnyDesk to give you remote control, and you can simply place that on an iPad and walk around your facility and connect into the computer wherever it is in your facility and remote control it right in front of it.
Beautiful.
So the software itself comes as a license. We also have a calculator that works in combination with this that allows you to input the initial product amount, the volume of your vessel, your target temperature, your target amount, or whether it's known or unknown, your amount of THCA that's inside of the material, and it will help you calculate a quantity of vents that it believes will be the complete process. We then use that in combination of our venting, which we consider a frequency, to create an estimated time target that will allow a user to be able to, I guess, accomplish a full production with no issues of cloudy carts that you can rely on and repeat over and over and over again at scale.
And discharge, the button discharge, that's for venting?
Yeah, so right now we have everything set up in a manual mode, or an automatic mode, but if I go into my controller settings and turn it to our manual function, our discharge button will now individually work.
I see.
And our charge button will work at any period of time, but we control that. This play button up here, this is the controls to your temperature controller. Right now it's only set on a single profile line, so you can set this into multiple profiles if you want to. This has just got 1, but you can add up to 10. They will work their way down it, and you have days, hours, and minutes which they could work through.
Beautiful.
When you simply hit play, all that will happen, it will come up and advise you that your set point is that. It will tell you your heater set point, and it has now changed everything for the temperature controller to start heating that mantle exactly to the temperature you want. When you press stop, it simply kills that temperature, and it will send it back down to the value of 0. Heat is off.
Beautiful. So today we're going to be using the 1 liter vessel. Corey was talking about leaving about a half a liter of headspace for the material, so we've figured out that'll probably be around 700 to 750 grams of rosin.
That's it.
We have also marked the vessel so that when it goes into here, we'll see that the top of the tape line is right where it goes to, and so we don't want the rosin going above this tape line. That'll ensure us that we have enough headspace with the lid of the unit plus the little bit of extra space here. That should be about half
That's
a liter.
500 mil of headspace, that's 1 liter. So we know no matter what, as you go with it, we spec vessels based on a body size, and then our head always has a known amount of airspace for that headspace. So we're always calculating the fact that it doesn't. The part that Corey has found the most unique out of this is the relative temperature change between inside of this mantle and the top of this glass vessel creates a condensation of terpenes, and you get a reflux, and you will actually recoat because that temperature shift is so drastic. It may be 150 to 175 degrees in here. It is about 80 degrees on top of that glass.
Okay. Excellent. So I guess we can start with throwing our rosin into the reactor. and then we'll see what kind of program we're going to run it through and start this this decarb. All right, so get a little bit of rosin in here. Actually coming out a little easier than I thought it might. Oh, we're gonna have to get the vessel tared and onto the screen, onto the scale, I should say.
I did get the weight of that on its own if you need it.
You did tear it already?
It should be 1,115.85.
1,116. 1,116.
All right, and then we got it wrong, something.
So yeah, just a little bit of, it's kind of got that round bottom. 2016. I'll just go 03. Fix that quickly enough. All right, so see if we can't get this rosin into that vessel. It's nice when you're in a cold room because you can actually get away with touching. That's where these silly gloves will come in handy that I've got on the way here. This is something else. This is going to be a big challenge. It's like I want to grab it from the bottom, but I can't.
It's going to make it worse. Your hand's just going to be stuck to it.
Oh, yeah. Oh, there it goes. That's okay. We'll get it figured out here. It's just going to be a nightmare, basically. Okay, a little bit of product. Okay, so 1,116 to 1,400. So we got a little bit less than half on there. I'm gonna take this glove off and throw on a new one. Calculator out as well. Just under 300. That's it. We managed to get some out. That was impressive.
Yeah.
So work like this could be done in the cold room. It's amazing how stuck it wants to be before it actually releases. You really kind of have to cut it from the bottom. I just don't want it to be too thick because I don't want it to
hit the sides.
To hit the sides at all. If I can avoid it, I will. Oh, this one has way less material on it. There you go. Let that fall down naturally. Okay. 1,817 grams. That's 700.
I'd say that's probably more than enough.
I think so too. So tare weight, gross weight is, well, it's minus the 11, so it's about 700, right? Yeah.
What was the total weight? Here, calculator.
The gross weight is 1,817.
Minus 116. No.
1116.
701.
1817 base 42. Net weight is 701.
Yep.
Points. Did you do the?
Oh no, I didn't know the end.
Here, I'll do them.
1817.42.
Here we go. We've got our rosin. We got about 700 grams in here. Into the vessel, and then into the reactor it goes.
So you simply place it in.
And then you've placed a small little
O-ring. Yep, there's an O-ring that comes with every vessel. That simply gets placed into the groove that's literally listed on the head.
that's going to create your seal and your vacuum.
That's it. You're going to slide the mantle underneath. We use a little stainless tray to make sure everything nicely fits underneath and stays balanced for us.
Okay. That's that little guy right there.
That's it. We have much better stands that we provide with the product. It's the demo ship easy one.
Yeah, well, we're doing
Line up your probe centrally, and then you're simply going to hold your head and loosen your two clamps to allow everything to slide down.
Okay.
As that slides, the probe will just press straight into the material,
Yeah, I can see that in there too. The probe is in.
and then all we're going to do is use the clamp, which has a preset nut attachment. And has a wing clamp. Simply going to just press it in. And remember, these things are tight because it's the seal that you're holding.
Yeah, of course.
And that's that.
What was that that came off there?
I think it's just probably a little piece of that little pin there.
Oh, yeah,
But
yeah,
it's
yeah.
just a piece of the clamp.
Perfect. Excellent.
So that's it. So then that's now sealed in place.
The rosin reactor is almost ready to go.
That's it. And then we don't have any nitrogen, so we're going to assume that I did a pressure test of the vessel before it came here, so I know it's going to be sealed. But effectively, we're going to make sure we've got all of our settings correct.
So you're going through the settings
We're
here?
going to go through settings, so we're in Rosin Reactor, we've got a Fahrenheit temperature, we're in a temperature control setup. Our logging file, yep, we want our pathway for our folder. We're going to prompt for a file name.
Perfect.
We then have our logging time interval, so this will log on a 30-second interval. There's also instructions on the right-hand side for all your settings.
Beautiful.
We're then going to go to our tank settings and switch to go into our auto high-low mode. Oh, come on. Gloves don't like
No, they don't. That's funny.
the screen. Enable our discharge mode. So we've now lost control of our manual discharge button.
Yeah.
We've set our trigger values, so our high trigger value is 5 psi, our low trigger value is 1 psi. Close our screen, and when we hit start, it's going to erase the background. We are then going to leave this as our file name, unless you want to change it to what you had for your, to that.
Yeah, RP23.002, and then I guess we could add the D, because when it comes out, when it's finished, it'll be decarboxylated.
We'll save that as our file name. So this is going to save and log as a CSV file. And two things have happened. Both the logging has started. Your graph is erased to restart. It started tracking the release rate for PSI per second. And it has started the heater.
So that's the release rate. You've got discharge mode, you've got ambient temp, product temp, heater set point, heater temp, as well as pressure low, pressure high, and pressure.
Effectively, the 5 on top, because this release rate will only exist when logging. It will disappear when not logging. But everything from the midpoint up is pressure. Everything from the midpoint down is temperature.
And so we've got it set at 180.
We're going to let it sit and let it increase in temperature. This is starting to auto-tune to get to the exact temperature of 180 degrees and set as a fixed temperature. And we're going to simply sit back and wait.
Beautiful. Excellent. Let's do some waiting. So I just asked Andrew, what we're actually waiting for, and he gave a good explanation, so we'll go through that real quick.
So we've now started the process. We're waiting for an initial build of temperature. Right now, our product temperature is only at 55 degrees, which means we most likely aren't having any kind of reaction take place. So we want to wait until our product temperature stabilizes. Once that stabilizes, you will then start to generate a frequency of venting. And that frequency of venting allows you to determine a time scale. If you have a known count of total burps that you're aiming for, and you have a frequency of those burps, our calculator then helps you determine an estimated time scale for that entire process, which helps with that very last 10%.
Right, the most important.
Usually pull, that's the part that's the biggest catch, because you've gotten 90% of the way there, and you've just hurt yourself by pulling it early.
All right, so we'll wait till it gets up to temperature. We'll wait till it starts creating that pattern for us, and then what do we do at that point?
We're then going to simply use that temperature and that ventilation frequency to determine what works for our time scale. If it's going too long, we're going to increase that temperature, which should then reduce the frequency and reduce the time, the time in between burps. Therefore, you're having a faster reaction. And we're going to target the right temperature to time process that works for both your facility as well as for the highest retention of these volatiles.
All right, beautiful. Thank you. One last thing, I was asking Andrew, so what do we got to do? We got to sit around and we got to watch this thing now and wait for it to get up to temperature? He's like, no, man, we're going to go to lunch because...
Everything is controllable on your phone. So we use a program that every single laptop is provided with. It has a name and a password to the PC, and you'll be able to see it. But right now, I can control everything that is taking place on that tank and computer from my phone.
From our lunch.
So we can simply just go out to lunch, monitor the entire process, go from there. And it was why we would say to people, if you want to connect it into a network and have a main PC, like we see here, but that PC is actually located in the manager's office, but then somebody who's that manager, if they have an iPad, they can very easily still be in this room and control it. They're the only person that can control it.
So will there be a subscription that you guys offer down the line where you kind of can like help monitor for people that don't know what they're doing maybe as well, and you can kind of give them a little bit of hand holding where, they're like, we're about to do a batch, little light comes on, or you get an email. Yep. Now you guys are monitoring for them and kind of maybe doing some of the math and organizing. They can tell you what they want. You tell them how to get it.
That's correct. Corey, who's my colleague, he will sit down and we have a package that includes this. He will give you, I think it's about 6 hours of time remotely for dialing in your process, working on calculations, and determining everything you want to do with the system. So it both works as a consultation aid as well as I guess the best way to explain it is a specific model that works for your facility.
I would call it white glove service.
Thank you.
For real. Just came in to do a quick check, and Andrew's just going to point out a couple of safety features that he got put in based on a friend who worked at OSHA, having a conversation with him. He just told me this, so he's going to be repeating it for the second time, but I thought it was important for you guys as well. So go ahead, Andrew, the importance of...
So we have a glass vessel that is pressure rated to 35 psi at 100 degrees Celsius. The manifolds all have a adjustable PRV, which can be, a plunger can be added for an emergency relief if you need to. We then have an analog pressure gauge and a manual ball valve. And they're all on it for worst case scenario situations where the vessel needs to be relieved immediately of pressure if it was ever to go over a certain amount of pressure, or if you don't have any kind of connection to this for any reason, you still know what's going on in this entire process.
So you definitely, in the SOPs, want to always make sure that you're checking this, making sure that it's closed, because if it's open, I guess we're never going to be gaining any pressure.
There you go.
All right, thank you. All right, so one of the things I wanted to cover with you, Andrew, was, there's a few different things that can fail on the unit. How hard is it to troubleshoot if something fails? Walk us through what that kind of looks like.
So basic troubleshooting you can use by the software, where there are 2 buttons onto it for discharge and charge that control both of your 2 solenoids for discharging and charging. By clicking them, you can simply easily check. There's an LED on top of each solenoid that will flash. We're not going to do it now because it's currently running live.
Yeah.
In regards to the internals, you have 2 temperature controllers that can easily be taken out by 2 bolts, and our main brain, which is effectively an embedded PCB board, and it's held on by 4 screws, and you simply switch the board out, and that's the main component change. After that, that's actually it.
Okay, so you have your two solenoids. You have this little plunger piece inside.
That's it. You can get to the inside of that valve if you need to by taking off that nut. You can get to the physical shaft, which can be unscrewed off the valve body. You can clean all the seals. You can get fully inside to it and then screw it all back together again. Underneath it, you have a 7-micron particulate filter that, once again, same thing. You can easily take out the filter, put it into an alcohol bath, clean it, and simply place it right back in again. Additionally, you can always adjust your automatic PRV if you want to go higher or lower. Everything is set to 35 psi, and after that, everything is a basic component switch out. The sensor for your temperature and your pressure is held on by a standard compression fitting, as well as your temperature probe is held on by a standard compression fitting. All of your sensors and solenoids are attached by M12 4-way automation cables, and all of that goes down to a single 12-way cable going into your board.
So fairly easy to troubleshoot and find a problem if you have one.
Correct. And fixing and replacing pieces are incredibly easy to do. The concept is you need one Allen key set to fix everything.
Okay, beautiful. Thanks, man. Hey guys, so yeah, now you've seen the Rosin Reactor in action. Unfortunately, I was unable to get footage. I wasn't there for the finishing up. I think it took us around 14 hours per 700 grams that we ran. We did end up doing about 2,700 or just over 2.5 kilos. We got it into carts, which I can show you the picture of the cart. Very nice color. The color in the labs when you're doing video, the rosin looked much darker than it actually was. It looked kind of like a peanut butter, but it was quite yellow, amberish color in the vape carts. The taste was absolutely phenomenal. We are waiting for the final COA in regards to showing that we got a terpene increase. Corey did hit me up the other day and let me know that he was getting a substantial increase in terpenes from a couple of batches that he did recently in Florida. We're quite excited with the unit, we got to admit. Taste-wise, decarboxylation-wise, we had the COA come in and it was like 100% decarbed to perfection. So this really allows you to get that 100% decarb and get it accurate. So you're not watching bubbles, you're able to monitor through your phone, which is great. And yeah, we're going to be using the Rosin Reactor here for a little bit. If anyone has any interest or questions about the Rosin Reactor, please feel free to reach out to me at bcbubbleman.com, or sorry, bcbubbleman@icloud.com. Send me an email. I can send you some information. I can hook you guys up with the company. I am going to be helping them move some units here in Canada and hopefully in the US. All in all, we're quite happy with the white glove service. We're quite happy with the fact that Corey was monitoring the decarb each and every time. And yeah, we're just, you know, more tools to be created for the industry that we're in that are designed specifically for these jobs rather than jerry-rigging and doing things sort of half-assed. So if you guys have any questions, I will try to do a follow-up video eventually showing the final process of us opening the unit. If you allow the unit to heat up, the rosin can be quite viscous, and that way you can take that and pour it right into your filling machines if you're doing vape carts, or get it back into whatever vessel you want to have it in before you get it into you know, edibles. So thanks for watching. As always, please subscribe, and we'll talk to you later. Peace out.